Here's the solution for day one, problem one. Simplify as much as possible. We have the square root of 50x cubed y to the fourth power. 50 is not a perfect square, but it can be factored using a perfect square. So let's rewrite this square root expression. Starting with the 50, rewrite that as 25 times 2. The reason I chose 25 times 2 is because 25 is a perfect square. Now for x to the third power, being an odd exponent, that is not a perfect square. So let's factor x to the third power as x to the second power times x. Now at least the x to the second power, part of that, has a perfect square. Finally, the y to the fourth power one. Because that's an even exponent, y to the fourth power is a perfect square, so we'll leave that one alone. Next step, let's take the square root of any of the factors that are perfect squares. That would include the 25, the x squared, and the y to the fourth power. The square root of 25 is 5. The square root of x squared is x. The square root of y to the fourth power is y squared. And then the couple factors that we couldn't take the square root of, we'll leave those inside of the square root symbol. So here is the simplified version of the original expression. Day one, problem 2. Factor the polynomial. We have a trinomial. The first kind of factoring you always look for is a greatest common factor. What's the greatest number that divides into 12 and 6 and 6? And that would be 6. Next, let's look to see if there's a variable that would divide into all terms. There is. It's x. Follow up the greatest common factor with a set of parentheses in which we fill in the other factor. 6x times 2x cubed would create the 12x to the fourth power term. 6x times x squared creates the 6x cubed term. And 6x times minus 1 will create the negative 6x term. Before we stop, we just want to analyze this factor here and make sure it doesn't factor any further. This is not one of the trinomials that has a particular factoring pattern to it, so we're all done.